lectures on instrumentation in process industries. So we are discussing the working of petrochemical plant, and in this we have discussed the layout of petrochemical plant and the process based on the layout of petrochemical plant, and we have listed 10 important petrochemicals and their uses, and we have listed various units in petrochemical plant, and next we have defined thermal cracking, catalytic cracking, polymerization, alkalization, isomerization. These are the important definitions in relating to petrochemical plant, and we have in detail discussed thermal cracking and fluid catalytic cracking. In this we have taken side by side design. In this, how the catalyst is pumped into the distillation column through by the regenerator. We have seen that, and after that, out of petroleum and natural gases, what are the byproducts available, and how those byproducts are used as a feedstock to the petrochemical plant we have seen. And we have considered distillation column and working of the distillation column we have discussed, and we have discussed the PI diagram of distillation column. And in this class we have to measure different physical parameters such as flow, pressure and density, and how they are measured and controlled we have to discuss in this class. Here we have to consider the measurement of flow throughout. You see, the throughput of a petrochemical plant is measured and controlled by flow instrumentation. That means the output efficiency of the petrochemical plant is decided by the flow instrumentation only. The flow measuring devices, flow equipment include vortex flow meter, positive displacement flow meter, the differential pressure type flow meter, and Coriolis type flow meter, and ultrasonic type flow meter, and rotameters. So these are the different kinds of flow equipment, and in this we consider vortex type flow meter because it is widely used in this chemical industry. So the vortex flow meter here placing a bluff body called a shedder bar in the path of the fluid. So this is the main item of the vortex type of flow meter. So the shedder bar, generally it will be placed in the fluid path. As the fluid passes this bar, disturbances in the flow called vortices are created. So the vortices trail behind the cylinder alternatively from each side of the bluff body. This vortex trail is called the von Karman vortex street after von Karman's 1912 mathematical description of the phenomenon. In the 1912, von Karman vortex described mathematically how this vortex phenomena occurs. After his name the waves fluid waves are named as vortices, vortex street. Observe here, the flow direction is like this. This is the vortex flow meter. One type of fluid meter that requires little or no maintenance is the vortex flow meter. So the vortex flow meter consists of a blunt, unstreamlined object such as a strut or a bar which is placed in the flow of the fluid. You can call this a shudder bar, a strut, or vortex bar, bluff body, shudder bar, bluff body, and strut, or simply you can call it as a bar. So this is the bar. So as the fluid is moving like this in the pipe, what happens is the fluid is passing through, not passing through, it is moving over the bar. Whenever the fluid is moving, what happens is because this shudder bar disturb the flow, it will obstruct the flow of the fluid. If you observe here, because of this obstruction, what happens is the fluid waves occurs like this. These are the fluid waves like this from bottom side and top side, and these are called vortices or vortex street. So the Corman scientist has developed the mathematical equations for this phenomena. So you can measure the vortices amplitude and frequency with the help of pressure sensor detector. Here it is placed here. This is the pressure sensor, and the frequency at which these vortices are passing, that frequency is measured and it is related to flow of flow rate of the fluid through the pipe. The frequency at which these vortices alternate sides is essentially proportional to the flow rate of the fluid. That means the is flow rate, for example, it is let us take it as flow rate V is directly proportional to the frequency of the vortices. And inside a top or a downstream of the radar bar is a sensor for measuring the frequency of the vortex setting. So this measuring device, frequency measuring device, this sensor is often a piezoelectric crystal which produces a small but a measurable voltage pulse every time a vortex is created. That means, for example, this is the pipe. Through the pipe, for example, here the piezoelectric crystal transducer is placed here, and as the vortex strike this piezoelectric sensor, then a voltage pulse is produced here. So this is measured. So the rate at which this pulse is produced, so that is measured. So since the frequency of such a voltage pulse is also proportional to the fluid velocity, a volumetric flow rate is calculated using the cross sectional area of the flow meter. That is, this is the pipe. We have to take the cross sectional area of the pipe like this. This is the cross sectional area. So by considering the cross sectional area, we can measure the volumetric flow rate of the fluid QV. So the frequency is measured and the flow rate is calculated by the flow meter electronics using the equation. Frequency is given by SV by L, where F is the frequency of the vortices, L is the characteristic length of the block body, V is the velocity of the flow over the block body, and S is the Strohal number, which is essentially a constant for a given body shape within its operating limits. So this is the frequency and flow rate relation. That means SV by L equals to frequency, and we have the frequency value available to us, and then V SV equals to F into L, and V equals to FL by S. So the Strohal number is fixed constant value that is available by the block body, and the length of the block body is also known. So these two parameters are known, hence the velocity of the fluid can be calculated by this. So with this we conclude our flow measurement. You see the vortex flow meter, how it plays important role in this we have discussed, and the important equation we have derived is frequency velocity equation we have derived, and the next physical parameter to be measured in the petrochemical plant is the pressure. So pressure measurement, how it is done in the petrochemical plant, let us see. Many oil, gas and petrochemical processes are undertaken at specific pressures. So pressure is measured by pressure sensors, that is the pressure equipment, which are arranged to transmit pressure transmitters signals to pressure controllers, that is PICs, that is pressure indicating and controlling equipment. And pressure vessels and tanks are also usually provided with local pressure indicators, that is PIs. So the pressure equipment, pressure transmitter, pressure indicating and control equipment, pressure indicator only. So here static pressure P is defined as the ratio between force applied perpendicularly to a surface with area A. That is, P is given by force divided by area. So here on the surface at point P, the force is acting upon. So the pressure developed by the fluid at the point P on the surface is given by P equals to F by A. So that is force is measured in newtons and the area in square meters. So Newton meter square is the units for pressure. Here pressure on an immersed body. So the parallel piped with a side A and length L area on one side, and where the pressure on its upper face and its lower face are given respectively by PD is the lower face, that is H rho G, and PU is the upper pressure, it is H plus L PG. The resulting pressure is equal to upper pressure minus down pressure is equals to LPG. So L is the length of the body and G is the gravitational force. Rho is the density of the fluid available. So this is the pressure on immersed body. Here because PD is equal to HPG and P upper equals to H plus L PG. Then if you subtract these two, H plus L PG minus HPG. So this is the differential pressure here, and if you open the brackets, HPG plus LPG minus HPG. So these two are cut, and finally the differential pressure is LPG. So this is the pressure on the immersed body. So the next physical parameter here is the density measurement. So the equipment uses a capacitive differential pressure sensor that communicates via capillaries with the diaphragms immersed in the process fluid separated by a fixed distance. The differential pressure on the capacitive sensor will be directly proportional to the density of the measured liquid. This differential pressure value is not affected by the liquid level variation nor the vessel internal pressure. So this is the density. Here if you observe, the density rho T is given by delta rho plus A into T0 minus T divided by GH 1 plus alpha into T minus T middle. So these are the density of the fluid. Here you see this is the different points we have to consider. So this is the height between these 2 points, tap levels 1 2, and you see from the top surface to this point 2, it is h2. From top surface to this fluid level to point 1 is h1. So the differential pressure on the capacitive sensor will be directly proportional to the density of the measured liquid. So this differential pressure value is not affected by the liquid level variation nor the vessel internal pressure. So the pressure P1 is given by rho g H1, P2 pressure P2 at the point 2, P2 it is given by rho g H2, and the difference of pressure P1 minus P2 is the rho g H1 minus H2. So this differential pressure delta P is given by rho g H. Here rho is the density, hence we have to derive the equation for the density. So rho is given by, if you move GH to the right side, then delta P by GH is the density of the fluid. T is the process temperature, delta P is the pressure differential, A is the filling fluid compensation coefficient, T0 is the transmitter calibration temperature, G is the local gravity acceleration, and H is the distance between diaphragms. A is a metal dilation coefficient, and T med is the measurement of H temperature. So these are the different parameters. Now let us see centrifugal pump. Centrifugal pumps contain one or more impellers that move fluid by rotation and draw fluid into the suction end of the pump, and then through centrifugal force forces it out of the discharge end. Centrifugal pumps can also handle dirty liquids or liquids with low viscosity as long as they do not contain air, vapors or heavy amount of solids. So centrifugal pumps plays important role because these the output streams, different streams in the petrochemical plant are pumped to different uh, destinations with the help of centrifugal pumps. So this is the construction of the centrifugal pump here. This is the suction nozzle. If you see, this is the suction nozzle here, and this is the discharge nozzle. The fluid comes to the suction nozzle and discharged through discharge nozzle. So this is the discharge nozzle, and this is the volute here, and this is the impeller. Yellow color is the impeller, and you have the seal here and casing. This is the casing, and here you find the oil rings. So this is the main shaft here, this is the main shaft, here the bearings. So this is the construction of pump. So this is the petrochemical pump. Here it is widely used petrochemical plant here. Petroleum products move from the upstream sector into the midstream sector of the petrochemical industry. So the midstream sector transports and stores natural gas and crude oils. This is where the petrochemical pump comes in. So companies use these types of pumps to process or refine chemicals during crude oil drilling and refining. Petrochemical pumps can be piston pumps, diaphragm pumps, mag drive pumps, or another type of process pump or chemical pump. So, petrochemical pumps can operate at high rates of flow and pressure within a refinery system. One of the benefits of petrochemical pumps is that they prevent leaks, thus, they prevent hazardous environmental conditions. The simplistic design of the petrochemical pump, ease of use, and compactness give it the durability it needs to keep up with the demands of oil drilling. On the downside, petrochemical pumps can succumb to overheating, cavitations, and internal corrosion. Viscous, toxic, and corrosive fluids can also wear down the impellers over time. Next, let us see the safety measures in handling petrochemicals. So, the safety measures are very important because personal safety is important whenever the human life is concerned. The most prevalent occupational hazards, generally process hazards, oxygen deficient atmosphere, chemical hazards, fire and explosion hazards, noise hazards. So these are the hazards, different hazards we find in industries. So these hazard conditions are to be taken into care, and necessary steps, safety steps must be taken so that to prevent emergency conditions. Let us consider the process hazards include leaks, spills, equipment malfunction, over temperatures, over pressures, corrosion, metal fatigue, and other such conditions which gives us process hazards. So whenever process hazards occurs, explosion of the particular equipment may take place, or it may trigger some other process for dangerous conditions. So these must be taken care. And next one is the oxygen deficient atmosphere. Here, release and accumulation of nitrogen gas in work areas may create asphyxiating conditions for a worker to perform a desired task. So, this suffocation and inability to breathe in condition for a worker makes his life in dangerous condition. So because of this nitrogen release and the atmospheric pollution may cause emergency conditions for the workers. And chemical hazards, the routine plant operations discharge chemicals like hydrofluoric acid, carbon monoxide, methanol, which expose workers to inhalation hazards. And dermal hazards include contact with the steam, acids, and hot surfaces. So, the chemical hazards are very dangerous because they give breathing problems to the workers, because these gases, carbon monoxide is dangerous one, and methanol also dangerous one, hydrochloric acids also dangerous, because if they contact with the persons, the skin may be burnt. So these problems must be taken into consideration and avoid such conditions. And fire and explosions. So the process operations include accidental ignition of gases in the release section, which lead to jet fires, pressurized release of hydrocarbons in high momentum gives this problem. So, pool fires, turbulent diffusion fire where fuel has low momentum. So, these are the problems. Fire explosions may take place because of these. We have to take care of these problems. And noise, large rotating machines such as compressors, turbines, electric motors, blowers, heaters are the principal sources of noise. The continuous and systematic safety management systems can identify hazards and analyze the associated risks. Emphasizing on OHS risks can provide a safe working environment to the employees. So, what are the strategies we have to apply to mitigate such risk and hazards in the petrochemical industry? Prior to commissioning, facility-wide risk analysis, example, hazard identification study, hazard. Hazard means hazard identification study, and quantitative risk assessment, QRA. These two reports must be prepared prior to commissioning, that is prior to work start. So these risk analysis will help us to prevent such hazard conditions. Following standard hazardous material procedures, which include shutting down all electrical activities during a flammable spill using surrounding safety equipment and other resources, and evacuation management. So, once the hazardous materials, if they release, then all electrical systems must be shut down so that it should not enhance the condition into danger. And how to evacuate the personnel, have you how to evacuate different personnel at different areas in the industry, you have to get a plan of action. And procedures for the management of change in operations, hot work permits, and safety systems of work. So these procedures must be developed and should be followed. and installing fire partition walls in areas that may be potentially affected by accidental releases of flammable liquids. So we have to install fire partition walls so that the releases of flammable liquids may not be affected. So, awareness of special emergency treatments for personal contamination with chemicals. That means we have to conduct certain training programs and training the personal workers about the emergency conditions and how to escape such conditions and know about the chemical that are flowing and in the industry. So those dangerous chemicals contact must be avoided. So such instructions and manual is to be prepared and given to the workforce. And providing early warning systems whenever a dangerous limit exceeds. So such warning systems must be automatic alarming systems must be initiated, such as pressure monitoring of gas and liquid conveyance systems in addition to smoke and heat detectors. So providing early warning systems is important activity to alert the workforce, and we have to employ smoke detectors and heat detectors so that they can be detect the hazardous conditions. It may give us a pre-warning system, warning signal to the workforce. And examining the mechanical integrity of process equipment and utilities at regular intervals. That means we have to continuously check the process equipment and the utilities associated with, and so that any repair is there or not, whether it is functioning properly or not, whether any abnormal sound or continuity of functioning is disturbing. Such parameters we have get, and this will decrease the chances of hazardous conditions. Simple safety trainings such as identifying unsafe work procedures or conditions and wearing PPE, that means personal protective equipment, while handling petrochemicals is important for the workers. So in this, these are the important strategies we have to maintain in the work environment of petrochemical plant. That is, we have to get the QRA report and hazard, and regularly we have to check the compliance of these reports with the physical equipment. Continuously we have to check and follow the standard procedures so that no such dangerous life threatening situations occurs. So we have, so these process hazards and oxygen deficient atmosphere and the process hazards in this we have considered regularly. We have to check the process equipment, its functioning, and different pressure temperature values, whether they are exceeding certain limit or not, and whether the process equipment is damaged or not. These things we have to regularly monitor. And whether nitrogen gas leakage is there, we have to detect that parameter, and because it may cause breathing problems and suffocation will take place to the persons. So these things we have to continuously monitor. And not only that, already I told you the chemical hazards. That means the chemical, some of the chemicals are very dangerous to the skin, may burn when we contact with such chemicals. So such acids, awareness must be known to the, must be given to the workers. And fire explosions may take place. To mitigate such things, we have to employ certain fire extinguishing actions, plan of actions, and we have to employ fire extinguishers at different locations. And the noise is also a disturbing phenomena, because this noise pollution may create a hearing problem to the workforce, so that this must be avoided. So we have seen the mitigation process, how to mitigate the dangerous hazardous situations, so that the operational of petrochemical plant should not be disturbed. So in this we can conclude our lesson. Today we have discussed in this lesson the measurement of flow and pressure of petrochemicals. In this, we have considered vortex flow meter, in which the bluff body is placed in the path of the fluid flow, so that vortex street will develop. That vortex street waves will will apply pressure on the piezoelectric transducer, which will gives us, for each strike of vortex wave, a pulse voltage pulse is produced, and frequency at which this voltage pulse is produced is the frequency of the vortex street. So that frequency is found. Once the frequency is found, which is proportional to the velocity of the fluid, so that can be related with the frequency is given by S F by L parameter, where Srohal number and length of the bluff body are the constant. Hence, the velocity of the fluid is directly proportional to the frequency of the vortex street. So by this we can find the flow rate volumetric. If you consider the area of cross section of the pipe, you can get the volumetric flow rate of the fluid. And in the pressure measurement, we have taken the differential pressure calculation in the fluid. And measurement of density of the petrochemicals also we have considered. The density parameter also we have seen in the differential pressure. With the help of differential pressure, how the density can be calculated, that we have seen. And we have discussed the centrifugal pumps used in petrochemical plants. And the centrifugal pumps and petrochemical pumps are, are very essential to run the streams from one place to other place. And we have considered, we have discussed the safety measures in handling petrochemicals. In this safety measures, we have considered the different hazardous conditions, how the two important reports, that is hazard and QRE. These two reports are essential for the hazard and QRE. This is a quantitative risk assessment and hazard is the hazard identification study. These two reports are very essential prior to the start of the work. And not only that, we have to give certain training programs, awareness programs to the workforce so that they cannot be casualties in future. So such things we have to consider, and we have to employ different regular basis checkups of process equipment so that process hazards should not take place. And oxygen deficient, that means nitrogen gas leakage and chemical hazards and fire explosions and noise problems also must be taken into consideration. We have to avoid such situations by adopting systematic plan of actions in the petrochemical industry. And we have to examine mechanical integrity, that is mechanical functioning of the process equipment in a regular intervals so that there should not be any defect in the process equipment so that we can avoid the problem of hazard conditions. So, with this, we conclude our lesson. We have completed the petrochemical plant. In this, we have discussed the all layout and important petrochemicals and their uses and unit operations such as thermal cracking, catalytic cracking, polymerization, alkalization, isomerization. We have discussed the most important cracking techniques, that is the thermal cracking and fluid catalytic cracking, in which heavy hydrocarbons are cracked into different small carbons. So those things we have discussed, and the distillation columns also we have discussed, and the physical parameters measurement and control also we have discussed, and finally we have discussed the safety measures we have to take and what are the strategies we have to follow to mitigate such problems we have discussed. Okay, thank you.